Hi, my name is Haley.
My name's Lauren.
My name's Riley.
My name's Quentin, and today our topic is bending.
Bending is the moment or torque around a transverse axis, and it is unique because it causes both compressive and tensile axial stress.
So before we want to go and start explaining this example to y'all, we want to explain what we meant by saying that bending causes both a tensile and compressive axial stress. And meaning so, a tensile stress will cause a lengthening in the area, while a compressive stress is going to cause a shortening in the area.
On the board, we have a femur, which is a long bone, undergoing external stress. As you can see on the left-hand side, the external stress is negative 2,500 newtons. The distance between the point of stress and the neutral axis is 0.075 meters. The height of the bone is 0.23 meters. The internal radius of the hollow bone is 0.15 meters, and outer radius is 0.2 meters. To find axial stress due to bending, we first must find the internal reaction force and the internal moment at AA.
So to set up our problem, to be able to solve for the axial stress, we just needed to first solve for the internal force and the moment at this section AA right here. In doing so, we know that we were able to set the net force and moment equal to 0, and with doing that, we're able to solve for internal force to be 2,500 newtons and the moment at 8A to be 187.5 newton meters. Okay, so now we're going to solve for our axial stress due to flexural loading, which is due to bending. And so there's going to be a different equation to do that. It's going to be our internal moment at AA times the outer radius divided by I, which is the area moment of inertia. And to solve for that, we used this equation and came up with our I here, and then our axial stress due to bending is going to be 43,653, and it's going to be a plus or minus. And to explain that, over here we have our tensile stress, and tensile stress is always positive, and it's going to be pulling up here on the lateral side of the bone, and our compressive stress is going to be negative, and this is going to be pulling down here at the medial side of the bone. So bending typically occurs in long bones, which is why we gave this example of a landing force on a femur and how that bending, the different stresses that it causes.
So another example of when a bending force would occur is spinal flexion, extension, and lateral flexion. And so for spinal flexion, whenever she's bending, there's a tensile force in the posterior side of her intervertebral disc and a compressive force on the anterior side of her intervertebral disc.